All right, here's the question. All the information here. It says also provided are some sample statistics. So we have our data down here. Some things note that this problem's actually incorrect. Why is it incorrect? Well, because this is a sample standard deviation, not a population standard deviation. So we should be performing a t-test, but you'll see here it has a z. So we're just going to stick with a z-test, even though technically we should be performing a t-test because we don't know sigma, but we can just assume that this is sigma. Okay, we're trying to show that something is less than the general average of 32 months. So our null is going to be it's equal to 32. Alternative is going to be it's less than 32. So in our calculator, we're just going to use this data. And we're going to hit stat test. We're going to do a z-test just because they have z there and not t. Enter your stats the way it is. 36, 4.31, 30.69, 36. We're trying to show it's less than mu. Calculate. So our z-score, or our z-score rounded to 2 decimal places is negative 1.82. And the p-value for this test is 0.034. The significance of alpha is 0.10 from above. So p is less than alpha. When p is low, we reject HO. So we reject the null hypothesis and accept the alternative. So we say we are 90% confident that the average age at which gifted children first count to 10 successfully is between. So now we need a confidence interval. So we're going to go back to stat, over to tests. And since we did a z-test, we're going to do a z-interval. And all your data should transfer over from the last problem we did. So we'll just change it to 0.9. And we get our answer here. This is going to be to 1 decimal place. So this will be 29.5 to 31.9. Both of these numbers are less than 32. So if we're 90% confident that the actual average is between these two numbers, that's the same thing as saying we know it's less than 32. So they do, in fact, agree.